Alright, boys and girls, welcome back to the drive-thru for a remix. We're going to redo this 12-3 video, and this time we're going to get the 3x3 determinant right. So, this is about inverse matrices and identity matrices, and then finding the determinant. Okay? The identity matrix, or matrices, are defined to be this. So there's a 2x2 identity matrix. You can see it's just a left to bottom right diagonal set of ones, okay? And I think what that means is if you take a 2x2 matrix and multiply it by this one, you're going to get the original matrix. Same thing if you took a 3x3 and multiplied it by that one. But we're going to use that more so with this fact, okay? Because what we're going to be working with matrices in solving equations involving matrices, and rather than doing all the multiplication, what we might want to do to get rid of a matrix is just multiply by the inverse matrice. So that's why these things are useful. So we know that two matrices are inverse if when you multiply them you get the identity matrix. Then we can prove. In fact, you got to multiply them in both directions, but I'm going to encourage you guys to use your calculator as much as you can by this. So you can do this times this, A times B, in your calculator. It'll just do it for you. And it should give you this for your answer, if these are inverses. I suggest you watch Daniel Chen's video. He has made a whole video of how to use your graphing calculator to use matrices. He's giving you helps on like 5 different things, so you should check that video out again. But here we'll just do it by hand, row by column. So AB is equal to, okay, that row, no, row by column, excuse me. That row by that column. Okay, so 1 times -2 is -2, and 2 times 3/2 is 3, so -2 plus 3. This one by this one. 1 times 1 is 1, 2 times -1/2 is -1. Okay, I like the way this is starting. Okay. That row by that column, we get a -6. 4 times 3/2, sweet, that is a 6. And finally, that by that, 3 times 1 is 3. 4 times -1/2 is a -2. And what you end up getting is 1 here, 0 here, 0 here. So now, if we did the other, so if we also did B times A, which I'm not going to do, and we got this, which you would, then we would know that these two matrices, A and B, are inverses of each other. Okay? So when you practice your homework, you're going to use inverses to solve equations using matrices. Just remember, an inverse is an opposite. The inverse of addition is subtraction. The inverse of multiplication is division. The inverse of A is called this. So you can just figure out how to do that in your calculator. Alright, the next thing you're going to need to know how to do is to find a determinant. 2x2 is pretty easy. 3x3 is where this video went bad last time. So, if you have a 2x2 matrix, to find the determinant, first of all, the determinant is just a number, so it's called a scalar. And the determinant is A times D minus B times C. Okay? So that's how you do that one. A 3x3 matrix is more complicated. So A, B, C, D, E, F, H, G, H, I. Okay. So, this is one thing that I'm better at, I think, if I could teach it live. And there are two different ways to do this. If you get done with this video and you don't like the way I just showed you, then I would suggest researching the other method to do a 3x3 determinant. But essentially, this is what you're going to do. You're going to take A, the top left, and you're just going to multiply it times the determinant, the determinant of E, F, H, I. Okay? Now this one was positive. The next one is negative. That's what I screwed up. So the next time, you're going to take B. Now, forget about that. You're going to multiply it by the determinant, of D, F, G, and I. Okay, and then finally, it's plus. So it's plus minus plus. You're going to take C and multiply it by that determinant. So the reason that I missed my board is I used to put my hand and cover up the column that you were eliminating. And now I can't do that on this inner right board anymore. Come see me if you guys have questions about how to do this. Or just watch the Daniel Chen video. You should be doing this in your graphing calculator. There's no reason. The whole point of matrices is that you can do math on a computer this way. So you should be doing math with a computer. You shouldn't really be doing these by hands. But if you're in a bind or if you're taking a high-level physics or calculus class, your professor might require you to do these by hand. So now you're learning how to do that. So rather than do an example and take too long, I'm going to kind of apply this. So one thing you can do with determinants is you can find the area of triangles. So Marty's mapped out a property he's looking out to purchase for his new farm. He's going to assign values for the coordinates. So let's just sketch a picture of this. Very wisely, Marty has called one of the points 0, 0. And then the property goes 1.4 miles in this direction and 2 miles in that direction. So we've called that 1.4, comma 2. And this is 1.9, comma 4 way up here. And what we have, what we have is this triangular piece of property. And Marty wants to find the area of it. Okay, so granted, we could use like distance formula 3 times and law of sines, and we could find the area of it. But this is just another way to do it. We're going to take the half of the determinant bounded by these numbers. So we want to find the determinant of 0, 0, and you literally just add a 1 there. 1.4, 2, and 1. Just making sure I write all these down correctly. 1.9, 4, that's a 0.4. Oh, I screwed that up all along. So this should be a 0.4, which means my triangle is not right, but we're still just going to go with it. So my picture is bad, but my answer will be correct. Now I want to show you how this works with numbers. So I'm going to take this 0, and I'm going to multiply it by the determinant of of 2, 1, 4, 1. Then I'm going to subtract the next thing. And that's going to be this 0, nice, times 1.4, 1, it's this, that, and that. 1.9 and 1. Keep in mind, this is 0. We know 0 times anything is 0. This is 0. And then we are going to add 1 times those. So obviously 1/2 of that is going to be the answer. 1.4 to 1.9, 0.4. So the answer, remember, we're looking for the area, and it's 1/2 of the determinant. So it's 1/2 of 1.4 times 0.4 minus 1.9 times 2. Now, as I'm doing this, I'm realizing I missed a really important part of this. It's 1/2 times the absolute value of the determinant. Because I can already see, I might be getting a negative answer. So the absolute value is just going to turn whatever this is and give it to me as a positive. So 1.4, I'm just going to do this on my calculator on the side here. 1.4 times 4 minus 1.9 times 2. Sorry, 1.4 times 0.4 minus 1.9 times 2. Indeed, so it's 1/2 the absolute value of negative 3.24. And so you get the area of this is 1.62 square miles. Okay, so hopefully that shows you how you might use a determinant. Now, when you get to vectors, it'll be way more useful than something as silly as that. You'll be able to show in 3 dimensions that things are, that vectors are perpendicular. That'll be very useful. So one more thing for the determinant. You can find an inverse matrix just using the determinant. Okay, so if A is equal to this, to find the inverse, you take 1 divided by the determinant, and then what you do is you switch the places of top left and bottom right, and then you just make the bottom left and bottom right, top right into the opposite sign. But as I stay down here, I would never do this. Our brains are priceless, and they have a limited amount of space, so I would never remember that. I would just learn how to use my graphing calculator to find a determinant. Hopefully this is better than the video that was not helping you as much. Have a great day. Boom!